Hey guys, this is Dan Sullivan again, and in the process of shooting another video, I realized all of a sudden that I had actually shot all the video that I need to demonstrate more precisely how the LOADpro works. I've had a lot of people contact me and tell me how glad they are they bought it, and I've had some people contact me and tell me that I'm an idiot for not really understanding how the power probe works, and any number of different responses, and that's fine. That's going to happen when you stick yourself out there for the world to see. There's always going to be a hater or two. At any rate, one of the things that I have tried to push somewhat successfully is the idea that we need to reconsider how we diagnose. And for those of you who might be supervisors watching this, I want to point out very plainly that managing electrical diagnostics is completely different than managing mechanical, because mechanically we see the problem quickly and we can immediately start to work, and there's a great deal of confidence in what follows in terms of the cost and the time and the effort and what needs to be done. And for the company, it's predictable, and that's comfortable. But the problem is, of course, that electrically we can't do that. And we have a problem because even though we can't do that, and you can rationally think to yourself, well, I can't find the problem in 5 minutes like I can a flat tire, it's going to take me longer, a lot longer, possibly. And if you don't understand that it's going to take longer to find the problem, but then probably only 10 minutes to fix it, if you think back to your past, to all those times when you've actually had to repair something electrically, and it ended up being one wire, one pin, one connector, one switch, something. And it took virtually no time to repair. So a lot of what I teach is based upon this assumption. And that's why I teach schematic reading and other things that some people would say, well, I don't have time to read the schematic. Okay, well, I understand that argument up to the point that I point out that argument doesn't make any sense, because electrically the first thing you should do is read the schematic, and that's what is actually going to teach you how the system and circuits work so that you can get better and better and better. Now, if you're a mechanic, here's where the problem lies for you. If the company you work for or the supervisor you work for does not encourage, promote, assist, and coordinate the use of the manuals and the schematics, and it just depends on where you work. I mean, some do, some don't. All right. But if the environment you work in doesn't promote that, I want to make clear one key point, and that is that you will not be able to do this work in the next 10 years, because the systems that are coming down the pike are way more complicated than they are today. And if you can't do basic electricity and basic diagnostics and basic meter reading and understand how to read schematics, then your future in this industry is going to be pretty bleak. And that's why I tell all of my students repeatedly that the only time you learn electrically is during the diagnosis. You don't learn during the repair. So taking 10 minutes to fix a green butt splice doesn't teach you anything, but the hour and a half that it took you to figure out how the system works so that you could get to the point where you know it's a green butt splice taught you a lot. Well, my argument is 6 hours is 6 hours, right? So if it takes you 6 hours to do a mechanical repair on a computerized vehicle, what if the next day the same vehicle comes in with an electrical problem? Don't you get the same 6 hours? I think you do. And anybody who says you don't doesn't understand the problem. So what I want you to remember is that we're diagnosing by asking the question, what's right, not what's wrong. Okay? Electrically, we can't know what's wrong. And anybody who asks you the question, what's wrong and how long, is an idiot, because those questions have no answers. And all they do is mess up the diagnostic process. So if somebody comes up to you and says, well, what's wrong? Or what do you think it is? The only honest answer you can give is, I don't know. And that's exactly what I say. I don't know. Well, why don't you know? Because I haven't finished the diagnostic yet. Well, how long do you think it's going to take? Well, it would take a lot less time if I wasn't standing here talking to you about it. It would be a lot easier if you'd, give me a cup of coffee and hey, let me sit down in your office where it's nice and comfortable and read the schematic and redraw it, and then, then we'd both understand it, and then, I'd probably be able to fix it in about 10 minutes. So I guess my answer is you'll have it back 10 minutes after I find the problem, because that's probably how long it's going to take to fix it. And what's curious about that whole exchange is, whether you realize it or not, if you're a supervisor, if you ask a person what's wrong electrically, you're asking them to lie. Because the only honest answer is, I don't know, and they don't want to tell you that. They would rather say, well, I think it's this, or it might be that. Well, that's a problem, because they just lied to you. They didn't want to do it, but now you're banking on what they said, and the whole process is screwed up now. So if you're a supervisor watching this, please do not ask the question, what's wrong or how long, for an electrical problem. Simply remind the guy that it's going to be something simple. Okay? It's going to be simple. It's not going to be complicated. There will not be $7,000 worth of parts. It will be 1/1000th of an inch of corrosion, or one broken wire, or one strand, or a short that's corroded, or a short, or an open, or a switch contact that isn't closing, or a set of relay points that are burned. By the way, burned for something else. Not because the relay burned because something else. And if it's a relay that's burning on a coil, like a solenoid, it's probably not the relay, it's probably the diode on the solenoid. So you need to check that. But this is an important sort of philosophy. And I get criticized a lot for what I say and what I do and how I do it. But I'm telling you, it works. Okay? And quite frankly, I don't really care about the haters, because there are always going to be those, and they don't change my mind a bit. I'm completely confident in what I know and how I say it. And I'm always willing to listen to better ideas, because I know enough to know that there are better ideas. But I also know that we have got to get this figured out. We have got to figure out how to make this process easier. Because if it doesn't get easier, it's going to become impossible. And if it becomes impossible, all hell's going to break loose. That's why I push what I call the voltmeter only diagnostic method. And the problem I've had as a teacher is that as a teacher I became an inventor. And inventors have to sell their wares, but then people make it, it becomes very easy for people to turn me into a salesman and forget the fact that I'm a teacher. And then forget the fact that it's not my fault that the patent office gave me a patent, and the only way to do what I'm teaching you to do is to use the tool that I invented. Okay, just so you understand, that position sucks really bad. And it's been a huge problem for me for a long time. And finally, I just said, screw it, I don't care anymore. What I'm teaching works. I've been teaching it for over 12 years. I invented the tool in 1999. It was patented in 2002. It works. It's for sale. The system is effective. And in spite of what a lot of people think, you really can diagnose a complete circuit with one voltage test. You don't have to use ohm meters. You don't have to use jumper wires. You don't have to pull connectors apart and follow, like I say, 46 steps on 7 pages. I mean, International Trucks has one procedure that's about 7 pages and about 46 steps to test one relay. And the only thing I can figure is that engineers get paid by the word, because it's crazy. And then I read another manual, I believe it was for Volvo, that spent 2.5 pages explaining how a potentiometer works. Well, if you just knew how a potentiometer works, they could say, this is a potentiometer. But we don't get taught that, which is why I did the video on rheostats and potentiometers, okay? So what I'm going to show you here, coming up, is the proper way to use this tool, which is the, this is the Blue Point version. There's another non-Blue Point version called, of a tool that I invented called the LOADpro. It was originally called Test Light Voltmeter Leads. It was yellow, and in fact, I just got a call today from someone who's had it since the beginning, and it broke and they need a new one. So thankfully it lasted about 7 years, I guess. But this tool works by loading the circuit. very simple, all right? And I've had some difficulty with other companies coming in after the fact and saying, hey, Sullivan had a great idea, let's do that too, and then, oh, he's got a patent. Well, we don't care. Okay. So you read voltage, and I want to make sure you understand something. There are only 3 faults that can occur in a wire, okay? 3 faults. Open, short to ground, high resistance. Think about that. Open, short to ground, high resistance. Those are the 3 faults. What does it mean when you see system voltage at the load connector? And by the way, the black lead goes into the connector 2, not the ground, okay? Because if you're doing that, then you're testing the entire circuit all the way back to the battery and all the way back to the ground from the battery, so you're testing the entire loop. So if you put the leads into the connector and not put this to ground, but put this into the connector, then you're checking the entire loop all the way back to the battery, okay? If you see source voltage, if you see 12 point whatever volts, 24 volts, you cannot have an open or short. Now stop for a minute and think about that. I don't care what the books have told you. I don't care what all the books you've read have told you. If you see source voltage at the connector, then all that means is you cannot have an open or a short to ground. Okay, and I want you to pause for a minute and think about what I just said, because that is not what the manufacturers teach. If you have source voltage at the connector for your load, for your motor, for your clutch, for your whatever, ECM, doesn't matter, then the presence of that source voltage means that you do not have an open or short, which in effect rules out 2 of 3 possible faults. That's not what it only means, that's what it really means, because it means a heck of a lot. Because seeing source voltage actually rules out 2/3 of every possible fault. Then you load the circuit. If the circuit can carry a load, the voltage stays normal. The loaded voltage stays normal. Okay? So you load the circuit and it stays 12 or 24, then there is no high resistance, because this tool works by causing a voltage drop. And it becomes the substitute load. So this becomes your clutch, or this becomes your motor, or this becomes your light, or this becomes your ECM. And you load the circuit, which is the same thing as turning the component on. And if the component's working, it should have 12 volts at it. So when you push the button and turn the tool on, the tool should have 12 volts at it, or 24. Okay? Well, here's the neat thing. If you see source voltage and you load it and you still see source voltage, guess what? You don't have a wire problem. It's over. You have effectively ohmed out the entire circuit from the positive back to the fuse, back to the battery, through the battery, all the way back around and to the ground. So when you push the button, it's the same thing as ohming out that entire circuit with one test. No jumpers, no ohm meter, no opening connectors, no wasting time, no work stands, no panels, nothing. You just read voltage. Okay? There are a lot of people who don't want to believe that, and there are even more people who don't want it to be true, because it changes the way we write manuals. And quite frankly, I'm convinced at this point that since no engineer has ever given me a technical reason why it won't work, and none of them returned the tools, by the way, when I asked for them, what it means is that they understand that they don't have to write a 500-page manual, Cummins. You can write a 150-page manual, Cummins. Because if you simply say, do you see source voltage at the connector? Load the circuit. Is circuit voltage still normal? Yes. Replace component. That doesn't take 34 engineers and 3.5 months to write. So let's face a little bit of a harsh reality here. Part of the reason that the books we get are so stinking complicated is because they're trying to think for us. Well, I'm trying to give you the opportunity to think for yourself, because all I care about is seeing source voltage and loading the circuit. Okay? So What's coming next is it's a board demonstration. It's not on a machine because it's easier to control. And what you're going to see is me use the tool to find a 1 ohm fault. 1 ohm, okay? And we can find it. And that's a dangerous number for AC clutches and ECMs. And I mean, there's 1 ohm is a lot in the real world, okay? Especially on the big stuff that we work on. So if you have any questions, you can obviously contact me, comment on the video if you want to, whatever. But the bottom line is this damn thing works. And if it didn't work, I wouldn't be pushing it, okay? Because I'm never going to make the money back that I spent on it. My parents gave me money that I used, and I'm never going to be able to pay it back because we're not going to sell enough of these things in my lifetime to really, help. Just flat out. Okay. Now the patent expires in 5 years, and I guarantee you that as soon as the patent expires, everybody and their stinking brother is going to be building this thing. Guarantee it, because it's that simple. Okay. So watch the video coming up. If you have any questions, let me know. All right. The nominal amperage through the motor is about 5.7, 5.8 amps, and the voltage is stable at about 11.73 or 11.74. 0.74 divided by 5.7 equals 2.05. 2.05 ohms, which means that a 1 ohm resistor increases the resistance by 50%, and a 1.5 would increase it by 75%. So let's do a little testing here and see what we come up with. My complaints about tools like this, and this one in particular, are numerous, and not the least of which is the sharp point, of course, is tacit approval for an uninitiated and uninformed person to poke holes in wiring insulation, which is a bad thing. Secondarily, the sharp point will go through the 1,000th of an inch of corrosion that will be causing the problem, and the problem will be missed. Okay, I'm going to put this resistor into the circuit. The fan noticeably slows down, and the 1 ohm resistor is dropping 3.57 or 3.56 volts. That is a substantial drop, and the fan appears to be working abnormally mechanically, and therein lies the basis of the primary problem. Okay, I've removed the motor, and the problem that we face as technicians is that mechanics want to go to the part. And the problem with this tool and others like it is that it doesn't show this problem. This problem is invisible to a standard unloaded voltmeter, and the primary advantage that this tool brings to the table is that it allows you to read voltage to confirm the absence of opens and shorts, if in fact source voltage is there. And then, by loading the circuit, we look for the third fault, which is high resistance. Let's show you the EECT 400, and we know the fault is there. We saw the amperage drop. The fault is there, and I want my technicians to be able to find this problem instantly. We turn the circuit on, and we get 12.8 volts, which is wrong. And it's wrong operationally. If you're a double E saying, well, that's what's there because there's no current flow, then you're a double E who does not understand the problem. Because the problem is, without current flow, we can't see this. If we can't see this, we can't fix the stupid vehicle. And anybody who sells a tool like this that doesn't load the circuit is doing a disservice to the person who is buying it. By comparison, if I go to the load connector, and I read voltage, and I read source voltage of, in this case, 12.85 volts, then that rules out opens and shorts to ground, because of the 3 faults, there are only 3 faults, and of those 3 faults, this voltage reading indicates the absence of 2, opens and shorts to ground. This is the way we should be diagnosing, not with ohm meters and jumper wires and 47 steps on 6 pages. You can do the entire circuit test with 1 voltage reading. So the 12.86 volts tells me that I do not have an open or short, but now I load the circuit and I see a drop of nearly 0.8 of a volt. And if you do the math according to the manual that we have provided, the math will point to a 1 ohm fault. The tool is that sensitive. So we see the drop in voltage. Now what I do is I move the black lead to a good source ground and repeat the test. And when I do, the problem comes back. And when the problem comes back, by default, in process of elimination, I know that the fault is in the positive side of the circuit. So without a schematic, without a manual, and knowing nothing more than the presence of that I should have source voltage present at this connector, I'm able to load the circuit instantly to see that I do in fact have a problem. It's that simple. Another aspect of the digital voltmeter in these leads is that in addition to knowing that I don't have an open or short, I can tell you that I do have an open or a short. Because if the meter shows this, ghost voltage, that's an open circuit. Pure and simple. I've been teaching this for over 12 years now, and it's never failed. And a short to ground shows up as true 0 volts. And this voltage reading is occurring because copper is touching steel in the circuit. We have a closed loop. The potential difference of the same point is 0. The meter is showing me 0, so I know that I have a short to ground. The key to this tool is it does not require a prediction. I simply read voltage, which the manufacturer tells me to do. I simply load the circuit. I see a drop in voltage. I move the black lead. I repeat the test. And without any prediction or any attempt on my part to understand the fault before I go looking for it, I know I have a corroded wire in the positive side of the circuit. Diagnosis over. If I'm looking for the fault of corrosion, I don't see it with this tool. What's worse is instead of seeing some indication that I have a open circuit, I don't. I get no indication. The tool is completely inoperative. If I want to see if I have a short to ground, meaning that my wire is touching ground, if I touch ground, look, no indication, the tool is completely inoperative. So I have no indication for a short, I have no indication for an open, and I have no indication of any value for a corroded circuit. None.